Morning all of you. I am Tanushri Dalai. So today we will discuss about your chapter 4, which name is Centroid and Moment of Inertia. So before we will start this chapter, we have to know what do we mean by centroid and center of gravity. So first of all, centroid is nothing but that is the point at which the total area of the plane figure like rectangle, square, circular and triangle is assumed to be concentrated, and the centroid of an area lies on the axis of symmetry. And the center of gravity means it is a point through which the whole weight of the body is assumed to be concentrated. So a body is having only one CG for all positions of the body. It is represented by CG or simply G. So what is the difference between centroid and center of gravity? So in case of centroid, it is defined as a point about which the entire line area or volume is assumed to be concentrated, but in case of center of gravity, here the point about which the entire weight of the body is assumed to be concentrated. In the second case, it is related to distribution of length, area and volume. In case of center of gravity, it is related to distribution of mass. Then we have to discuss center of mass. So the point of an object at which all the mass of the object is through to be concentrated, that is known as the center of mass. So there is some important points we have to remember. So the CG of a uniform road lies at its middle point. The CG of a triangle lies at the point where the three meridians of the triangle meet. The CG of the rectangle or the parallelogram is at the point where its diagonals meet to each other. It is also the point of intersection of the line joining the middle point of the opposite side. And the CG of the circular section is at its center. Hence, the centroid and the CG of the circular section is same. So here is the center of gravity of various geometric section. So you can see this is the rectangular section which center of gravity act at this point, which value is h by 2 in y direction and L by 2 in x direction. Similarly, in semicircular case, the CG will be act 4r by 3 pi from the bottom of the section. Similarly, in case of trapezoidal section, the value of CG from the base is equal to h by 3 into b plus 2a divided by b plus a. In case of conical section, the center of gravity is acting at 2/3 r sine alpha by alpha from the top of the section. In case of hemisphere, the value of center of gravity is 3r by 8 from the bottom of the section. For the cone, the value of center of gravity is h by 4 from the bottom of the section. After that, axis of reference. So to calculate the center of gravity, we have to know the axis of reference. So the center of gravity of a body always calculated with reference to someone assumed axis known as axis of reference. It is also sometimes with reference to some point of reference. The axis of reference of plane figure is generally taken as the lowest line of the figure for calculating y bar and left line of the figure for calculating x bar. So now we have a problem. So there is a T section which is given in this question, and the dimension of this T section is 100 mm into 150 mm into 30 mm, and we have to find out the center of gravity of this T section. So you can see in this figure the T section is made up of two parts. One is flange section and another is wave section. The horizontal one is flange section and this vertical one is wave section. The dimension of the flange is 100 into 30 mm. So you can see this is your 100 mm, this is your 30 mm, and the total height of the T section is given as 150. That means the height of the wave portion is 150 minus 30, that is 120 mm, and the length of the wave is given as 30 mm. So now first of all we have to see in which axis the total section is symmetric. So you can see if we cut this section in the YY axis, then it will be a mirror image. So that's why this section is symmetric about YY axis. Hence here the center of gravity we can find out in the YY axis. So first of all we need to separate the total section into two parts. So as you can see, the flange is one other part and the wave is another part. So first of all, for the first section, that is the flange section, we have to find out the area and the centroid, that is the y1. So for the section 1, the area of the section is, so you can see that is a rectangular portion. So that's why the area of the rectangle should be 100 into 30, which is equal to 3000 mm square. Then y1. So y1 is the centroid of the section with respect to reference axis. So in this case, the reference axis or the reference line or the axis of reference should be the bottom of the section. Okay, so that's why we have to find out the centroid or the CG of this section with respect to this reference axis. Hence, in case of rectangle, we know that the centroid or the CG is acting at b by 2. So here this one is the b, so that is 30 mm. Okay, so 30 by 2 is the CG of the rectangle, but with reference to reference axis we need to add this much distance, which is 120 degree. So that's why we can solve in this way, or we can also solve because here the total height of the T section is given, that is 150. Hence, by deducting the CG of the rectangle of first section from the 150, we can find out the y1 value. So 150 minus 30 by 2, that is the value of y1, which is equal to 135 mm. So this is all about for the first section. Then coming to the next section, that is the wave portion. So for the wave portion, the area of the wave is equal to b into d, as it is a rectangular portion. So that's why the b value is 120 and d value is 30. So 120 into 30, that is 3600 mm square, and the y2 value, that is the CG of the second section, that should be the d by 2 because it is a rectangular portion. So d value is 120 and d by 2 is 120 by 2. Hence 120 by 2 is equal to 60 mm. So as we know that to find out the center of gravity, we have the formula, that is y bar is equal to a1 y1 plus a2 y2 divided by a1 plus a2. Hence here putting the value of a1, y1 and y2, we got the value of y bar, which is the center of gravity of this T section, is equal to 94.1 mm. So this is all about the center of gravity of T section. So today this much. Thank you.